Good morning, all. This is a 120th Tech Talk from Tech Forum. We all welcome to participants, like-minded people and participants. This session is precisely on technical information and research information, which will be presented by today's eminent speaker, Amruta Pasarkar, Dr. Amruta Pasarkar. The topic she will explain you in detail. Let me talk little more about the Tech Forum. Tech Forum is a forum of like-minded people founded in 29th June 2021. This is a fifth year. In this fourth year, we are consistently following the various Sunday Tech Talk. More than 120 Tech Talk we have followed. We have completed. These are the technical information presented by various eminent speakers. Then we have done 15 plus offline Tech Talks. The personalities from various industries and sectors are participated and given their knowledge base to like-minded people. We also celebrate a full day technology day every year. We have made such 3 technology day. We celebrate national and international day. More than 8 national and international day we celebrated, and we are going to keep continue. We organize and participate also workshops and open event day every year. So the friends, uh, this is the Tech Forum, has a history of consistency and continuity. One of the motto of Tech Forum is to bring upfront and expose and give their exposure to new research people. We have conducted such type of technical talk on new research from the day one at various locations, including offline and online TikTok. So today's speaker is Amruta, Dr. Amruta Mayur Pasarkar, Assistant Professor, Department of Mechanical, Bharati Vidyapita and College of Engineering, Lavle, Pune. She has done a wonderful research in hardfacing of 316L, stainless steel and its fatigue behavior. So let us hear from her about the research. I pass this session to hand over this session to Amruta Pasarkar. Please carry on, madam.
Thank you, Anil sir. And before starting off the session, I would like to thank the Tech Forum for giving me this platform wherein I can talk about my research and about the future research work that I want to do and how I can contribute to the industry and where this particular research work can be useful in the industry. So myself, Dr. Amruta Mayur Pasarkar, and I am working as an assistant professor in Department of Mechanical Engineering, Bharati Vidyapit College of Engineering, Lovely, since last 10 years. And I have done my PhD from Vellore Institute of Technology under the guidance of Dr. Balaguru sir on the fatigue and tensile behavior of the 316LN stainless steel, hard-faced 316LN stainless steel. So the today's agenda of the presentation is here. First, I will be explaining about importance of hard facing, how the hard facing is done. Then about the importance of 316LN stainless steel, where exactly this particular material is being used. Then about the cladding material which is used and what all are the different hard facing materials that can be used on such substrate. Then the deposition processes, what are the different kinds of deposition processes can be used. Then the high temperature fatigue testing and how this fatigue testing is done, and a few industrial applications. And last, I would be also explaining what some few results of my research and what I want to do in the future. So what is hard facing? Basically, just yes. So what is hard facing? It is a wear resistant layer, or it is a layer that is applied on a base metal. So this layer is harder than the base metal. So here you can see this is a geometric figure which I have given to understand that this particular gray material is the base metal, and on that the cladding is being deposited. So this cladding is of very minimal thickness. It can be of 1 mm, 2 mm according to whatever is the application required. So this is here one example I have given here, which is the on the base metal, the on the base material, the cladding is being done. This is the hard facing or the powder is being hard faced on the base metal. So this is a wear resistant alloy layer is being put on the base metal. Now, what are the benefits of this? It will extend the service life, and then what are the techniques that can be used is shield metal arc welding can be used, gas metal arc welding is used, gas tungsten arc welding is used, then plasma tungsten arc welding is plasma transferred arc welding, and laser cladding can be used. There can be any more hard facing techniques, but these are the major techniques that can be used. Then applications are in mining, agriculture, construction, and power. I will be explaining all these points in detail in the next slides. The how to choose the material that is being hard faced is very important. So that is again one big challenge, that what material needs to be used. Then next is the material is selected according to the hardness, what hardness is required according to the application, and the toughness, what kind of toughness is being required to avoid the cracking, because after this particular cladding material is very hard as compared to the base metal. So there should not be any cracking also in the during the hard facing or during its operation. The need for hard facing. So this it avoids the wear and corrosion on the particular base metal, and it increases the surface hardness, and it prevents the material degradation in high friction and corrosive environments, and it extends, obviously this will extend the component and service life. Now, more about the 316Ln stainless steel base metal, which is being discussed in this particular presentation. That is, the 316Ln stainless steel is basically low carbon. L is for low carbon and N is for nitrogen enhanced. So it has some amount of nitrogen and it has a low carbon. So low carbon is below 0.03%, and that prevents the sensitization, and which can and the also the enhancement of the nitrogen. It gives more of the yield strength compared to the standard 316L grades. And this particular component, this particular base metal or this particular material, it has excellent resistance to corrosion and excellent resistance to pitting. So this particular material is used at very environments which has very aggressive temperatures or aggressive environments, so that it can, because it has a very higher hardness and it has a very higher tensile strength, so it can maintain its hardness in the elevated temperatures also. Now, how is the cladding that is done on the base metal? How is the cladding that is being selected, or how do we select what material needs to be used for the cladding? So first is the coefficient of thermal expansion. What is the coefficient of thermal expansion of the cladding and the base metal? So that needs to be checked, because the if there is a lot of difference between the thermal expansion coefficient of the cladding and the base metal, then it will cause stresses at the particular interface of the cladding and the base metal, and it will lead to cracking. So matching of the coefficient of thermal expansion and the of both the materials is very important to reduce the stresses at the interface. Then the metallurgical bond. There should be a very good metallurgical bond between the two between the powder and between the base metal. Because if there is no fusion between the two, then it is obviously going to crack, or it is obviously going to break. Then the wear resistance. So selection is based on the specific abrasion and the scaling mechanism in the application. So there are many types of alloys that can be used, but mostly the cobalt-based alloys and nickel-based alloys can be used as the cladding material. So cobalt-based alloys are stellite 6 and stellite 21 can be used. I am talking this specifically for 316Ln stainless steel base metal. If the base metal is something different, then the alloys the powder alloys or the coating can be done with any other material also. But I am talking specifically about 316Ln stainless steel as the base metal. So this is the about the cobalt-based alloys. So there are two alloys that can be used, that is the stellite 6 and stellite 21. So basically these are used for general purpose wear resistance and high temperature stability. And this also improves the ductility and resistance to the thermal shock in the cyclic environments. Now, nickel-based alloys. Basically, cobalt-based alloys are prone to radiation. So wherever the nickel-based alloys are used, they are used as they are radiation stable, and it avoids the cobalt-induced radiation activation in the nuclear plants. Also, the nickel-based alloys have very higher hardness, and it can maintain its higher hardness at elevated temperatures as they are in the nuclear reactors around 500 to 700 degrees Celsius. So we can use this nickel-based alloys for superior oxidation and corrosion resistance also. So basically, nickel-based alloys are used wherever there are very higher temperatures, as it can maintain its higher hardness at elevated temperatures. Hard-facing deposition cycle. Now, how is this hard-facing basically done? So first is the surface preparation, like the cleaning and degreasing of the 316Ln substrate, and to make sure that there are no contaminants or there are no debris or any the surface is very clean. And then on that, the preheating of that particular base metal is done, and after the preheating, the clad deposition is done by the various methods. So any method can be used as per the requirement and as per the application of the industry. So the applying the material with either laser cladding or plasma tungsten arc welding or gas tungsten arc welding, and the parameters of these particular processes needs to be decided so that the proper hard facing can be done on the base metal. Now, after the cladding is done, then the controlled cooling of the particular component is being done. And after the cooling is done, the component is machined, or the cladding layer is machined to get a plain and normal surface. I would like to mention here that if anyone has any doubt regarding any of the slides, then you can please interrupt me and ask me during my presentation also. Otherwise, we will take the questions. We can also take the questions later after the complete presentation. Now I am discussing about the different hard-facing processes. So the first is the laser cladding. It shows minimal dilution, and here you can see this is the particular one image which I have given about the laser cladding. So here, this is the cladding region. The upper one is the cladding region. The below is the base metal of 316Ln, and this particular small line that we can see is the interface between the cladding and the base metal. So here we can see that very precise, we have achieved a very precise line from the laser cladding, and the dilution is also very less. So laser cladding is, it gives very refined microstructure and a very precise interface. And the microstructure is very fine, and due to the very fine microstructure and very small grain size, the hardness is also very high in the laser cladding. Just a minute. Next is the different arc welding processes, that is the plasma tungsten arc welding and gas tungsten arc welding. So these are the two major arc welding processes. Now, plasma transferred arc welding, it gives better dilution control as compared to the gas tungsten arc welding. I will be also discussing about the comparison of these processes later on. I'm just discussing about the brief points about these processes. Then is the gas tungsten arc welding, which has a lower equipment cost, and it can be used for manual surfacing also. Now here we can see this is the image of the gas tungsten arc welding. So here we can see the thickness of this particular interface is a little higher as compared to the laser cladding. So, but the gas tungsten arc welding process is more easier as compared to the other processes, and the equipment cost is also lower. Uh, the comparison of these three processes, that is the gas tungsten, plasma transferred, and the laser cladding, is the heat input required for the gas tungsten arc welding is much higher as compared to the other two processes. The dilution is much higher for gas tungsten arc welding process as compared to the other two processes. And the shear strength of the laser cladding is very much higher than the other two processes. So from this particular table, we can see that there is different heat input, there is different dilution, and different shear strength required as for the all the three processes. So depending upon the application, depending upon the cost, and depending upon what kind of hard facing or what material we are using, we can choose any of the processes. Then what about the fatigue loads? So what is the importance of fatigue loads on this 316LN stainless steel? So basically, when the hard facing is done, the hard facing, the two materials are different. So the cladding and the base metal both are different. So because of the continuous expansion and contraction on the at the interface, the fatigue loads and the tensile loads are being acted on the at the interface. Then the mechanical vibration induces cyclic loading, potentially leading to the crack initiation at the fusion line. Also in fluid systems or high power fluid systems, the pressure wherever the liquid pressure is very high, the uh, the fatigue loads can be the fatigue loads are acting on the on such hard facing components, and due to these fatigue loads, the cladding layer can break, or it can break at the interface, and also due to the sudden rise in the hardness. So what happens when we do the fatigue cladding? When we do the cladding, the hardness increases suddenly from the interface in the cladding region. So if there is sudden rise in the hardness, then obviously the component is going to break in the fatigue or the tensile loads, and it will cause cracking or debonding of the cladding. So because of all these reasons, it is very important to understand the fatigue and tensile behavior, or how it acts in the during the operations due to the fatigue and tensile loads. So this particular hard-faced components, it should be able to carry the thermal loads or the tensile loads as per the applications. Now, how this fatigue testing is done is we can simulate the thermal loading, the CTE, that is the thermal expansion coefficient. The stresses can be simulated between the alloys and the base metal. Then the fusion line analysis, the metallurgical analysis is done by the microstructures. Microstructure analysis can be done, which I had shown previously, to understand if there is any micro cracks in the interface. Then the cyclic testing is done using low cycle fatigue or high cycle fatigue loads as per the applications and as per the requirement. And the structural validation, like analyzing the results of the high cycle or low cycle fatigues from the SN curve, from the table format, and the review of the how the bond is being created, and if it is the fractographic studies can be done after the cyclic testing to understand from where the cracking is being initiated, from where the how is the crack propagation is there, and how the particular component is failing. So the industries where the 316L and hard-faced fatigue testing can matter is I have noted down some industries where, like the thermal power industries, wherein we have the turbine blades, the boiler tubes, and where high temperature cyclic loads are being acted on such particular component. Then aerospace and space industries, where the thermal cycling is there during the takeoff and cruising. Then nuclear power industries, wherein the temperature operates between 500 to 700 degrees Celsius under the mechanical loads. So this is an example of where I have shown one component which is being used in the nuclear reactor. So this is the grid plate here, which is hard-faced. This grid plate is hard-faced. Now, this particular whole component is being situated in the nuclear reactor, which is being surrounded by the sodium liquid. And because of the higher pressure of the sodium liquid, which is around this particular component, and the higher temperatures of around 500 degrees Celsius, operating temperature of the nuclear reactor is around 500 to 700 degrees Celsius. And because of this higher pressures of the sodium, what happens is the fatigue or the tensile pressures can be created on this particular grid plates or the support structures inside the reactors. So wherein this fatigue testing is very important to understand how the particular component is going to take its load at the higher temperatures and pressure. Aerospace industry, so gas turbine engines, landing gear components, again, their thermal cycling is being thermal cycling is there during the takeoff or the shutdown. And here these require high strength, fatigue resistance, and protection against abrasion. And the thermal power industry, wherein the boilers are there, the superheater components, the steam turbines, wherein there are very much higher temperatures and the aggressive environments inside. So these components are going through very aggressive environments wherein they need to wherein they need to sustain the fatigue pressures and the stress pressures. Now I would like to just explain what research I have conducted till date. So I have taken, this is just in a brief. So first, initially, I have taken the 316 sheets, and on that, the hard facing was done by nickel alloy, that is the Colmonoy alloy, because my specific the application was for the nuclear industry, wherein the specific application was of the grid plate, which is used in the nuclear reactor. So that is the reason I have used the nickel alloy, and by using the plasma transferred arc welding process, gas tungsten arc process, and LC process, the hard facing was done. Then I have prepared the tensile and the fatigue specimens, after which I have done the microstructural and hardness studies on these specimens to understand what are the grain sizes, and what how the if the proper hard facing is being done, and there is proper fusion between the two metals. Then the tensile and high cycle fatigue tests were conducted, experimental tests were conducted, and then the macroscopic and fractographic analysis was done on the fractured specimen to understand how the crack nucleation was there, how the cracks are propagated, and how the fatigue properties, basically to understand the fatigue properties, and the comparison of all the properties was being done. All the processes, the three processes that are used, the comparison of all the properties were being done for the three processes. So these are the brief results that I have got through my research about the microstructure. So the grain size was being seen least for the LC specimens. Then the thickness, the fusion line thickness was again being seen least for the LC specimens. Then the hardness was seen most for the LC specimens, it was the highest. Then the tensile results, the tensile strength, that is the ultimate tensile strength, was seen the highest for gas tungsten arc welding process. Okay. Then the fatigue analysis was also being done. So the fatigue testing also it showed the highest fatigue strength. The gas tungsten arc welding process showed the highest fatigue strength. So how I can contribute to the industry from whatever experience I have got till now is the material failure analysis, then conduct the SEM, and that is the scanning electron microscope and electron dispersion experiments to understand the failure analysis, to do the failure analysis, and ASTM testing standards, to use the ASTM testing standards for the failure analysis. Then process optimization, then if any specific process needs to be used, then how the optimization of the process can be done considering its various parameters like the speed, or at what temperature it needs to be done. So optimizing of the process, if any specific process needs to be done to increase the component life and to give a good hard facing over the substrate. Then the mechanical testing and design validation can be done with like the tensile testing, the hardness testing, and analysis of all these results. The analysis can be done using experimental analysis and also using ANSYS or MATLAB, because I have also used ANSYS and MATLAB during my research work and during my PhD. So I can also do all these analysis and all these testing using ANSYS, and also the experimental testing, and data-driven recommendations for the design optimization. And I can do the hands-on on the metallurgical lab operations, and data interpretation, then technical writing and presentations to the stakeholders, as I have published three SCI journals. I've published three papers in elsewhere with impact factor of around 5.7 in the elsewhere journals. Then I would very well like to bridge the gap between the R&D and the production, and how we can relate the research and the production. Future research, what I want to do is whatever, like I have explained it previously, that whatever research I have conducted previously, I have conducted it at the ambient temperatures. So I am looking forward to conduct all these tests at higher operating temperatures of the SFR, the higher operating temperatures, that is around 500 to 700 degrees Celsius. So basically to take the 316L in stainless steel, and to do the hard facing with gas tungsten and laser cladding, and to prepare the tensile and fatigue specimens, and to conduct, I am interested in conducting the tensile and the high cycle fatigue tests at 500 degrees Celsius temperature, 500 to 700 degrees Celsius temperature, so that the actual component, the actual temperatures can be utilized for this particular testing, and then do the analysis on all these tests. Thank you. So if I request if anyone has any questions.
Uh, Thank you very much, Professor Amruta Pasarkar, for explaining the really hard-facing subject in a very simple manner, unfolding various insights of your research and activity. Now, by this completion of your presentation, I request participant to start asking the questions and give your opinion and guidance to Amruta Pasarkar. Then let me begin with my first question. Uh, I request you to just tell us about where are you carried out this test and experiments, and what type of test you carried out.
Yes, I have carried out these tests in Mumbai in TCR Engineering Services. I have carried out I have carried out high cycle fatigue test
Okay.
and tensile test needs to be carried out before the high cycle fatigue test. So majorly I have carried out high cycle fatigue test in TCR Engineering Services in Mumbai.
Okay. These are practical on-job tests,
Yes.
not the virtual.
No, no, no. Experimental. I
Okay.
can show you I can also show you how the tests were being conducted and how the results were being obtained. But these are actual practical tests are being conducted in the metallurgical lab.
Oh, great. Now, there is a one information or the question has been raised on a chat box by Mr. Makaran. Mr. Makaran, if you are there, can you please introduce yourself and ask your question?
Hello, I'm Makran. My throat is also as bad as the madam. Madam, take care of your throat because of this pollution. Everything is getting bad. Anyway, I don't have a question. I just shared some my experiences. But you can comment on the cast iron on the surface for the same purpose. Please put your light on that cast iron over the surface.
Okay.
You understood the question?
Yes, use of cast iron as the cladding material.
Cladding or you can like that.
Yes, actually, so this is hard facing, which this is specifically hard facing, which is done at the thickness is very minimal, around 1 mm or 2 mm, and it is just like a coating, like we do the
Yeah,
yes, we'll do the paint on the wall. So that is just a
yeah. Mhm.
coating that is being
Yeah.
done. So which is of minimal, very minimal thickness. So normally powders are being used to do such kind of processes. This is not welding process wherein two components are welded together, but this is a hard facing, it's a kind of a coating process wherein the two metals or the powder and the substrate metal is going to melt together at the interface, and it is going to join together.
Mr. Vishwas Kale, are you there? You please guide us and tell us something interesting. Look like he's not there. He just get out of presentation. He will join again back. Anyone else, Mr. Rajhan sir?
One query.
No, I don't have any query.
Okay.
I would like to have one question. This particular process, I think your more focus was on fatigue test, not on the cladding. Am I right?
Yes.
The
Yes.
cladding process is done in India by any agency?
No. Cladding process I have done here in laser cladding. I have done in Pune, Magod Fusion.
Okay.
Laser
That means
cladding I
you
have
are
done here in Magod Fusion in Pune.
so you have done the cladding process also, and then
Yes, I
fatigue
have
test was carried out. Correct?
both. Yes, both.
Okay.
Both.
Have
But
you approached any industry for this research?
sorry, I did not hear.
Did you contacted any industry for this research?
During the research?
No, now after completion of the research.
No, not as yet. Not as yet.
So what are your future plans of utilizing this technique or technology, whatever you have developed?
Yes, I want to actually extend this because I have done all these testing at the only specimen level. So I want to extend this at the higher, at the component level, the testing at the component level on the higher machines and like, for example, if it is a grid plate, on the actual grid plate, the testing needs to be done. So
That
this
means
is just an example.
this particular testing you have to carry it out at the industry level, where
Yes,
such
yes.
chips are manufactured and cladding process in a bulk is done.
Yes,
Correct?
yes. Because now I have done this particular testing in a lab or in a metallurgical lab. So this needs to be done on a higher scale, on the actual component
Have you
and
done
at
any
higher
testing?
temperatures.
Have you done any testing on the cladding that you did, laser cladding, and whether it meets the industry norms?
Yes. I have done the testing on the cladding on the hard-faced laser cladding also. Laser cladding,
Okay.
gas tungsten, and plasma transfer.
So all those tests, whatever research or whatever process you have done, is industry approved?
Yes. Now these tests are where I have conducted these tests, it is NABL accredited lab. So I have got all the results from them, and they can be approved by the industry because the results are in line with whatever are the processes.
Okay, thank you.
I have a question. My name is Ganesh,
Yes.
representing EduFuture. Namaskar, Professor. It's a wonderful activity. I have a question mostly from the non-technical perspective.
Okay.
Now, if this has to be implemented, continuing what Sir was speaking about, if this has to be implemented in industries, what, according to you, will be the cost saving for the industry? Have you done it on part of the research? Has it been one of your outcome? What will be the cost savings in terms of manufacturing for the industries when we get all these things implemented? It's absolutely non-technical question because this is what industries, from an industry perspective, we are interested. If I do all this, what is the cost saving for me? End of the day, I need to see profits. What are your thoughts on that, please?
Right. So I think we need to, regarding the cost savings, we need to first decide what particular process needs to be used, because there are many processes like gas tungsten is there, plasma transfer is there, laser cladding is there. Sorry. So we need to first clear out what particular process needs to be used, and basically gas tungsten is the very effective as compared to the other processes as per the cost is being concerned. But again, there are other parameters and other properties also which needs to be considered according to what is the customer requirement and how the cladding, or what till what thickness the cladding needs to be done. So accordingly, we can decide if, for example, if GTA process is being decided, so accordingly, according to the customer requirement, we can decide how we can reduce, what parameters we can use for doing this particular process, so that the cost is being reduced, and at the same time we are going to achieve the expectations, and we are going to achieve the proper fusion and proper thickness without any cracks at the particular interface. So we need to go according to that.
But has it been captured in your research, please?
No, cost consideration I have not considered in my research.
Okay. Anyway, thank you, Professor. Thanks for your time.
Thank you.
So, as I understand from this question, was a very interesting question and really industry required question, that how cost is concerned with this research. Basically, I found that required specific technology which you want to use, or the method you want to use, and the problem statements. If take that process detail along with the problem statements, if any industry has already utilizing this, then can be evaluated again in a way of cost benefits, as I
Yes.
understand this.
Yes.
Thank you, madam.
Optimization can be done.
Optimization can
Of
be
the
done, and which is required.
parameters can be done according to the requirement.
How much life can be increased in this case? Do you has idea that at least 2 times, 3 times in terms of simple word? Or only the saving of time, only the saving of cost, or expansion of life of that component also?
This particular research which I have done, this expands the life to 40 years of the nuclear reactor service.
Which is expected to be otherwise?
40 years of the nuclear reactor service. So it will very much extend the life at a good this thing level.
Yeah, long life. So
Yes.
entire technology got changed in the 20 years. So you have given the double the life. So excellent findings and interesting sharing. Any questions, please?
I think she has done quite a good work. I feel the Tech Forum should take it up and connect her with some industry, so that industry and she both can be benefited. Rather, both will be in a win-win situation. That is what my suggestion.
Yes. Mr. Vishwas Kaleji also commented on this yesterday. He got a time to interact with me, and he is there available on Tech Forum platform to give us an industry exposures and connections. So I request Amruta Pasarkar to contact Mr. Vishwas Kale. We'll provide you
Yes.
the detail contactable. Also, please be in touch with Tech Forum. There are many industries and challenges available for you to know and make further research effectively.
Yes.
Because being an industry person, we have a complaint about researchers. Let me come to frank area, that researchers do the research, take the doctorate designation, and forgot. So we feel that why we are working hard, very much hard, and you are not you as an alone. Researchers are not part of our industrial development. So to fulfill this gap, Tech Forum is very much interested in doing these exercises, which we did couple of other research peoples also. For example, one research we carried out, one presentation we carried out, and some industry people, two industry people offer him a land around 2 acre and 5 acre land at various locations for carrying out his research and example works. So as well, you need suppose specific equipments or specific any guidance. We have as a tech forum platform, we have a connectivity in interface connected to many industries. You will get it exposed and your time will be saved, and research and activity will be done in a much faster time. So this I would like to offer from behalf of Tech Forum and our like-minded people. So
Thank you, sir.
if there is any next question, we will carry, or we can
So my
conclude now.
question was a very from first basic. Yeah, this is for fatigue or this is for corrosion, cladding.
Yes, sir.
This is for
fatigue or
this is
this
for
is for
fatigue or this is for corrosion? Your
This is
research.
actually, this is for the fatigue strength of the component, of the hard-faced component after hard-facing. After hard-facing, what is its mechanical behavior, what is its mechanical strength, what is its tensile strength, what is its fatigue strength after hard-facing.
So that means
okay.
post hard facing is a post-mortem of the component.
How it behaves
But
under fatigue loads. How it
the
behaves under the fatigue loads.
hard facing is done for corrosion or a temporary thermal fatigue.
No, no, no. Hard facing is basically done to reduce the corrosion.
Okay, but you mentioned about thermal also.
Thermal, uh, this is for example, there is a component and on that the hard facing is done to reduce the corrosion and the wear properties. But this hard-faced component, like for example, the grid plate is there in the nuclear reactor. So this grid plate is hard-faced with some nickel alloy, and this is used in the nuclear reactor. So this particular component, it is hard-faced. So now because of the sodium which is there, the sodium liquid which is there at high pressures around this grid plate, this particular liquid, and because of the higher temperatures of 500 degrees Celsius, the liquid pressure, it causes the loads, fatigue loads, and the mechanical loads on the particular grid plate, which is hard-faced. So that is why the testing needs to be done. Only if the base metal is used, then there is no requirement of the testing, or there is no requirement of fatigue testing to be done. But this is the hard-faced component. This is these two components are being joined together, so they should not break at the interface due to these fluid pressures or due to the sodium pressures. So that is why the fatigue analysis or the tensile or the mechanical testing needs to be done on the particular hard-faced component.
You mentioned about the boiler also.
Yes, yes, yes. So wherever there are these extreme high pressures and high temperatures, there these tests needs to be done. There these fatigue tests needs to be done.
So it's a thermal also, thermal fatigue
Yes.
also.
Yes, yes, because there is temperature that is being related. So that is why the thermal fatigue will also come into consideration.
Okay. So thermal fatigue plus mechanical fatigue.
Yes, yes, both.
And because of the cladding.
Yes.
Once you do
Thermal
the
fatigue,
cladding,
mechanical fatigue on the cladded material.
right. Once you do the cladding, actually it's a dissimilar material than the base alloy. So the both must be behaving quite differently.
Yes, yes, that is the main this thing, because both are behaving differently, but they are fused together at the interface. They are fused
They are not
together at the
alloy.
interface. Yes.
Okay.
So that is the reason these tests are done. Fatigue or the mechanical tests are done to understand its behavior under these kinds of loads. And it should not break apart. It should not The cladding should not break apart if there are any loading conditions, if there are high pressure conditions on these particular uh, components.
Micro level crack also will be finished. Everything
Yes,
will
yes,
be.
yes, yes. I have all done that. I have seen those cracks, formation of cracks. Few of the specimens do not show any cracks because the fusion is very good between the two components and between the cladded layer and the base metal. And but few of the components they show the cracks that are being formed because the fusion is not good. So this fusion should be, this bonding should be so good at the interface that it should not fail due to these loads that are being carried out due to these loads on the component in the actual this thing environment.
The cladding word actually sometimes mislead, because I understood cladding means it is like a covering the by the sheet, okay, and it is welded at some end, so that that is the end of the end corners or whatever you can call it as.
Okay.
It looks like a continuous cladding. It's like a surface coating.
No, it's not. It is kind of surface coating, but it is a coating, very small thickness coating, but it is
Yeah.
fused together.
Hmm.
Both the
So it is
both the elements are fused together at the interface. That is why the dilution concept also comes into picture, because the surface, the base metal, the components of the base metal are being they are being fused with the cladded material.
that means in continuity. They are in
Yes,
continuity.
yes. So there is melting of the two components at the
Hmm.
interface, and then they
At the
fuse
interface.
together to form as a one.
Mhm. They are not like simple. Cladding is very quite mistook word actually.
Mostly
ज्यांना cladding माहिती आहे.
hard facing is used. Hard facing and cladding, both the words can be used actually.
हा हा.
So they are fused together, and after the fusion, after the full process is done, they are acting as a one simple component of two different materials, but the component is only one.
Okay.
Yes.
I feel the session is going on very good, interesting. Information itself is an very informative, interesting, and something different what we hearing today. Otherwise, this subject is really tough to understand for a common man or the other industry person, non-technical persons. So, Dr. Amruta, you have explained really good wording in a simple wording the topic. We can take a last
Thank you,
question
sir.
if anything. We have still 7 minutes to go, or we can conclude the session.
Anil ji, your comment, then VPR's comment and AD Future's comment actually were the quite logical and quite sensible comment, because it was related to the cost and cost benefit to the user
Yeah.
after the research. So I
Thank you very
think
much.
now, actually, I think that we both are actually conversing. Actually, it is now the beginning of the next step after the research is over. That
Yes.
how to make it presentable in the form of cost benefit and costing and profit. What you mentioned, any future Ganeshan, na? Ganeshan.
Thank you, sir. Yes, sir. This is Ganesh, sir. Thank you very much, sir.
So
Thank
that
you
was
very much.
actually that's now the beginning has for the madam. Actually, this is beginning was started now from today
Yes,
onward. That the beginning should be now about the focus on cost and benefit to the customer on the first slide itself.
yes.
The first presentation slide should be benefit to the and cost and what are the benefits.
Mm-hmm.
So that is the beginning, and the three of them actually among this group, three of them actually given you the hint. And Kale also, Vishwas Kale, you also mentioned about the same thing. So you can take instead of answering their question, तुम्ही आता त्यांच्या मागे लागा आणि ते करून घ्या काम तुमच्याकडे
Oh,
त्यांच्याकडनं.
right, right.
दे विल गाईड यू. फोरम
Definitely,
विल गाईड यू. फोरम विल गाईड
definitely,
यू.
definitely. मला हे करायचंच आहे पुढे थोडं म्हणजे हे मला न्यायचंच आहे अँड आय विल बी डेफिनेटली डुईंग दॅट.
In fact, I just like
बरोबर
to
ना?
add over here. I just like to add over here
हा.
to all to the ladies and gentlemen. I'm working on Academy Industry 5.0. I really
हा.
would really, I would really be, sort of, very much appreciate if, the professor can get associated with this through Tech Forum. So I'm working on this going forward, how exactly the future education has to be. And Professor, I represent NAC and I represent in NBA.
Okay.
Interesting, sir. Behalf of
Yeah,
Tech
yeah.
Forum, I would like to give a confidence that best of the best industry people, we will be connect to you on your
Sure, sir. Sure,
topic.
sir. We are blessed. I thank you for your blessings.
Yeah,
Definitely would love to meet you, sir, at your convenience. Thank you, sir.
yeah, thank you. And I also wish Dr. Amruta Pasarkar that your research should initiate many new things in the industry. Especially new innovations or product upgradations or process upgradations and savings the time and cost of industrial products. This is what is the ultimate. Otherwise,
Right.
research, being a research in a paper, we should get out of this model and try to convert them in a actually practical systems. So Tech Forum is by all means available for you and the people like you all over the industry. And once again, I really say thanks to you presenting everything. Uh, I think by this conclusion, we should conclude now the session.
Thank you.
I would also like to thank Tech Forum for giving me this platform and allowing me to present my work
Yeah.
in in this platform.
So,
Thank you very
Amruta,
much.
on behalf of Tech Forum, we wish you all the best. And
Thank you,
today's
sir.
presentation was quite educative and informative. So, have a wonderful day. And those who are joining for the first time can become Tech Forum member. Have a nice day. Over to you, and Anil.
And
Yes.
wishing
Thank
you
you,
all a
sir.
happy Republic Day, sir. Coming.
Yes. That is a pleasant day tomorrow. We should really be happy to wish all a happy Republic Day. Thank you very much. And I declare that the session is over.
Thank you,
Thank you
sir.
very much.